Hi there, welcome to the video for Vectors 3. This is focused on finding the magnitude of vectors and how we can use that for various purposes. Now, you've met finding the magnitude before, but we know that we can think of the magnitude as the length of the vector, and especially when we draw vectors and we kind of illustrate them, we can definitely think of it as the length. So we've got some vector A. If we want to find the magnitude of it, we're wanting to find the length of that vector. Now, if that vector A is 4i plus 2j, kind of 4 steps across, 2 steps up, then I can use Pythagoras. Okay? My right angle triangle with lengths 4 and 2, and so I can plug it in to the Pythagorean theorem. Now, this is some new notation. If I put A and then 2 straight lines either side of it, that's the magnitude of the vector A, okay, the absolute value of A, so the magnitude of that vector. And then we'll square root this, we get root 20, which we can write as 2 root 5. Okay, so it's as simple as that. We're going to use Pythagoras to find the magnitude of a vector, and it's as simple as using I and j coefficients or the column vector kind of coefficients for the Pythagoras. Now, as well as being able to define kind of a magnitude of a vector, I also might sometimes be asked to be able to find the angle made between vectors. Okay, so as a way of kind of defining what actual direction they are going in. Now, for instance, if I have this vector A, which I can kind of say is 4i minus 3j, I want to find the angle that the vector 4i minus 3j makes with the positive x-axis, so makes with kind of the x-axis that would be here. Now, to do that, again, I can use my right angle triangles and I can use my trigonometry this time because I'm trying to find an angle. So I want to find this angle theta, and I know that I have the lengths 4 and 3, okay, 4 and 3. And so it's as simple as thinking, okay, I've got the opposite, I've got the adjacent, that means I'm going to be using the tangent of theta. The tangent of theta is 3/4, so I'm going to do the inverse tangent, and I get the answer of 36.9. Now, with these questions, it's worth being really specific. This is 36.9 degrees below the x-axis, because obviously if it was above the x-axis, it would be pointing in a different direction. Okay, so 36.9 degrees below the x-axis is a really perfect answer. The other thing that we're going to be able to need to do using the magnitude of a vector is to form a unit vector. Okay, so we know that a unit vector is any vector with a magnitude of 1. So, e.g., the I and j vectors that we've already met, those both have a magnitude of 1. But we also want to be able to make any unit vector in the direction of a given vector. So any vector, however defined, we can make that into a unit vector. So we can make it into having a magnitude of only 1. Okay, to do that, we're going to divide the vector by its own magnitude. Okay, now this kind of makes sense. We're going to by dividing it by its own magnitude, we don't change the direction. We know that. Okay, we know we're not going to change the direction of the vector, but we will reduce the magnitude. Okay, if we divide it by its own magnitude, the magnitude will reduce to 1, and something divided by itself is 1. Okay, so for a vector A, the unit vector, which is in the same direction as A, we define as this. Now, this again is some notation, but it's something important to make a note of and to remember. So this A with a circumflex, or A with a hat, A hat equals the vector A divided by the magnitude of A. Okay, so this is the unit vector. This is how we denote the unit vector in the direction of A. The unit vector in the direction of A is A divided by its own magnitude. Okay, so let's have a look at some examples that will help us with this. So let's have a look at a vector B, which is negative 6i minus 8j, and we want to calculate the magnitude and then the unit vector in the direction of B. Okay, so part A, nice and simple. I am interested in Pythagoras. If you need to draw it, draw it. It's going to take you 2 seconds, and if it means you're going to get it right, I'm fine with it. But I can say that the magnitude of B is kind of applying Pythagoras' formula. So the square of negative 6 plus the square of negative 8, all square rooted. 36 plus 64 is rooted, so it gives me the magnitude of B as 10. Now, I want to find this unit vector. So this B hat, unit vector in the direction of B, is the vector B divided by its own magnitude. The vector B is negative 6i minus 8j. The magnitude of B is 10. Simple as that. So this is the same as negative 6 over 10i minus negative 8 over 10j. Sorry, minus 8 over 10j. And then I've got B with a hat is negative 3/5 I minus 4/5 j. And that is it. I can double check that, a good sense check, an easy way of going, right, let me make sure this makes sense. I can just quickly, using my calculator, square 3/5, square 4/5, and then square root the sum of those two, and I should get 1. Okay, I should get that the magnitude of this vector is 1, because it should be a unit vector. Okay, it's a really easy way to check. If you haven't got a unit, the magnitude of 1, you haven't quite got the answer correct. One more example then. I want to calculate the angle formed between the vector 6i minus 3j, and the unit vector j. This is my vector 6i minus 3j, and straight away I want to work out the unit vector j. Where is it? What am I dealing with? So the unit vector j points straight upwards. Okay, so you won't always be asked to deal with the horizontal. Sometimes you'll be asked to deal with the vertical, or it could be any vector. The vector could point off over here. Okay, so draw your diagram first, and then work out what you do. Now, in each case, we're going to be working with Pythagoras. Well, sorry, not with Pythagoras. With trigonometry, with our right-angled triangle. So I know I'm going to be dealing with this triangle here. Okay. Now, that gives me a clue as how I can find the total angle between j and this vector. One key thing to note is as well, I've drawn the vector j from the origin of this vector. Okay, I've not drawn it down here because I'll get a more acute angle than I want. Okay, I want to draw it at the origin up here. Okay, but this kind of shows me I can start thinking, how do I find this total vector? Well, it's like, I know that this is a right angle, and then all I need to find is this and add them together. Now theta is nice and easy to find because I know these are 6 and 3. Okay, 6i minus 3j. And so I can use the tangent of theta is 3 over 6. That's the opposite over the adjacent. Inverse tangent of a half, or 3 over 6, gives me 26.6 degrees. So the angle formed is 90 degrees plus 26.6, so it's 116.6 degrees.